Hello YouTube, this is Blackberry Pie in Minecraft. So, this is the first of a series of videos I will be making on Redstone logic, and its applications. And this video will be about the very basics of Redstone, so you might not need to watch it. But you could learn something you didn't know before, even if you think you know Redstone. If you're intermediate. So, we're first going to look on blocks that give off power. And we're going to start with the humble lever here. Now, a lever has two states, on and off. That's very simple to understand, yes. And it gives off power in a specific way, and that is, if you pretend that the lever was a whole block here, rather than just on the side, this whole block would give off power. To the left, to the right, in front of it, and then also underneath it here, as you'll see. So I'm going to go ahead and put that lever back on. So you'll see this underneath it receives power, as does right, left, and in front of it. Now, also, the block that the lever is attached to, this block here, it also gives off power to all adjacent blocks, as you can see, like so. And next we have the button. The button is similar to the lever. It has only an on and off state, and we're showing it on the side of a block here. But rather than when you click on it changing between states, when you click on it, it will become powered for a short time, and then it will become unpowered. And the way it gives off power is the exact same as a lever on the side of a block here. Right. So that's a button. Next, I'm just going to show a short demonstration that the lever can be built on top of a block, and the block gives off power, and so does the lever. So just the same way as the first lever did here, but it's only built on top, so these four blocks adjacent to it will be the only ones receiving power from the lever block. Alright. Next up we have the wooden pressure plate, which is going to function pretty much exactly like the lever on top of a block. So it gives off power to all adjacent blocks if you pretend the wooden pressure plate is a block giving off power. And then also the block underneath it here gives off power to all adjacent blocks. And a wooden pressure plate is activated when either a player steps on it, or a mob steps on it, or perhaps even better, when an item is dropped on it. Now, an item that is dropped has a timer of 5 minutes exactly before it despawns. And so you can make a clock with a multiple of 5 minutes from a wooden pressure plate and items dropping onto it. And then another use of a wooden pressure plate is in an item factory, where the output items drop onto the pressure plate, which activates a wire, which activates an indicator light, so you know when your item factory has produced items and they are ready to be picked up. Next we have the stone pressure plate, which is the exact same as the wooden pressure plate, except that dropped items will not activate it. But players and mobs still will activate it. And then, lastly, we have, well actually I should probably just step on this real quick. Lastly, we have the detector rail, which is the same as a stone pressure plate, except and a minecart only is the only thing that will activate it. A player or mob won't activate it, so only a minecart will activate it. And it gives off power the same way as pressure plates and a lever on top of a block. those are almost all of the blocks that give off power. The last one is the redstone torch, which is the most interesting out of all of them. The redstone torch is this guy right here, who you most often see in my hand. And it gives off power the same as a button or a lever or a pressure plate, in that all of the adjacent blocks give off power. But rather than the block it is attached to giving off power, see, the block does not give off power, the block above it gives off power if it's opaque. So this block here above it will give off power. I can put a redstone on top and you'll see that it's powered. And to the side will give power, and the same on the other three sides. Now if I remove this block, or if I put a transparent block here, it will not give off power. So it is only opaque blocks that can give off power above a redstone torch. Next up is how blocks are powered by redstone wire. And then we'll go into further details about the torches and stuff. When a block is has a redstone wire on top of it, it powers the block that the redstone wire is on top of. But that block itself does not give off power from being powered by the wire. Alright? And at the end of a wire, if there is a block on the same level as the wire, then this block will receive power from the wire. So the blocks below the wire are powered, and the block at the end of a wire will also be powered. Alright, now back to the redstone torch. The redstone torch is useful, extremely useful in fact, because it turns off when the block it is on becomes powered. So here we have a redstone torch on the side of the block, and here we have a wire running over the block. We're going to remove that, and we're going to put the wire here. So this block is not being powered, and you see the torch is on. Now if I put redstone on top of this block, we know that the block will become powered, and the torch will turn off. Just like so. And if we remove the wire or we unpower the wire, the torch will turn back on. Fascinating. And this will also work at the if the end of the wire is going into a block on the same level as it. See here the torch is off, and if we unpower this block, the torch becomes on. And you can do funny things with torches and blocks and torches, like when this torch is on, this block is powered and all 5 of these torches are off. And if I power this torch, then if I power this block, then this torch becomes unpowered, which means this block becomes unpowered, which means all of 5 of these torches turn on. And next is the limitations of redstone wire. Redstone wire has a limitation of only being able to carry charge for 15 blocks in length. So if you were to count this out, this is the 15th block right here. You can still see the little particle effect poofing up from it. And this is the 16th block, which is not being powered by the wire. Alright? Now, 15 blocks would be plenty for any small device, but if you were going for something really massive, 15 blocks is not nearly enough. So how would we increase the signal? The old school way, actually, let me mention this this bug real quick. It's not really a bug, it's just in the game. If you have a torch on top of a block next to a wire, it will not become unpowered. even though it kind of looks like it's jutting into it, this block does not become powered. It has to be at the end of a wire, like this. So if I run a wire out one, that block will be powered. If I do just this and put a torch on top, the wire will bend towards it, but it won't power it. Alright, where was I? Increasing signal length. So, the old school repeater was using a redstone torch's property. If I power this block here from the signal, actually, let's go all the way down here. If I power this block from the signal and turn this torch off, then I can have the inverted power here go another 15 blocks, or I could just immediately have it power this torch here, and then the charge from this torch would carry for another 15 blocks. And this is the old school repeater, which is using 2 NOT gates built together. And this you would have. This was the old school way to increase the length of a redstone signal. But with the 1.3 update, which is now quite some time ago, the repeater block was added. And a repeater does the same thing as that whole contraption did, but it's all in one block. And it also does some other things as well, which are quite useful, as we will see in just a minute. The repeater will increase the signal length for 15 more blocks. And how it receives power is very specific. The block behind the repeater, if it's a wire that is powered, the repeater will be powered. And if it's just a block being powered, the repeater will be powered. Wait, that's not supposed to happen. Right, so if I do this, the repeater will be powered. And if I remove this, this should actually unpower, but for some reason my game is glitching. Now, if I run a wire on top of the block to power the block, it will still power this repeater. So if the wire behind it is powered, or if the opaque block behind it is being powered, the repeater will be powered. But only from this block behind it. You can't power a repeater from the block in front of it, block to either side. It has to be only the one behind it. This allows the repeater to function as a diode, which we'll get to in just a minute. And also, the way that a repeater gives off power is very specific. If we have a repeater being powered here, and you have a redstone wire on the same level, it will be powered, and this can go for 15 blocks further. Or, if you have a opaque block being powered by the repeater, because you can power an opaque block with the repeater, this block gives off power just like a block receiving power from a button or lever or pressure plate does. So this block will give off power on top of it, to the side of it, below it, to the other side of it. So that is extremely useful. But if there is a transparent block, the transparent block does not give off power. And you can't build wire on top of a transparent block, just as a side note. So yes. And here we have a series of repeaters, and I'm using them as a diode to separate this wire, which goes over here, from these 2 wires running along the side here. And I can do that like so. Do 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 ding, do 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 do. And also, they won't power the wire to either side. So this is a completely separate signal from these 2 wires running on either side. And the final feature of repeaters is they have a settable delay. You can change how long it takes before the signal is repeated. It starts at 1 tick, goes up to 2, 3, and finally 4 ticks per repeater. And a tick is 1/10 of a second. So if you have 5 repeaters all set to 4, 5 times 4 is 20, that's 20 ticks. Divide by 10 ticks per second, and that's 2 seconds before when this repeater is powered to when this wire is powered. So when I flip this lever, it will take 2 seconds before that wire over there is powered. And also, it takes the same amount of time for the off signal to be transmitted through it. So it will take 2 seconds from after that I flip this lever till this is off. Yes. Now, going back to redstone torches, there is a very specific quirk with them called the north-south quirk. And this direction here is north-south. And this direction here, that's east, and this is west. But if you have 2 torches on blocks north to south, then they will update on exactly the same tick. So when I pull this lever, both torches will turn on and off at the same time. And this is a very specific quirk that only happens north and south. If you built this east and west, each torch would have a 1 tick delay, because almost always torches have a 1 tick delay each. Alright? So if I turn this off, this would turn on after 1 tick, which would turn this block, all of these torches, off after 1 tick. So it would take 2 ticks before these torches are off if I remove this wire. So it's not instantaneous. And this is not instantaneous either, but it happens in only 1 tick rather than 2. And then an interesting use of repeaters is to push signal through a solid wall. Let's make this nice and checkered. Because of the way repeaters can be powered, and because of the way they give off power, you can put signal through a wall using 1 repeater, either on one side of the wall or the other side of the wall, or both. And let's see. Here we have another wire showing off the 15 block limit, but all snaky, and you can see the shortest distance between 2 points is a straight line. So if we make the wire all snaky, 15 blocks ends right here rather than all the way down here. That's a big difference. Alright, and finally for this video, we're going to go over vertical signal transmission. We've shown horizontal transmissions rather easy. You just have wires and repeaters and whatnot. And we've shown transmission through a solid, an opaque wall. And next up we have vertical transmission. The simplest is just having a staircase, a spiral staircase. But you have to keep in mind the redstone's 15 block limitation gets used up rather quickly in the spiral staircase. But the nice thing about this staircase is it's both traversable, and also the signal can go up through it or down through it. So this is useful for a short distance in either direction. But if you had a really, really long distance, you would want to use this for transmission going upwards. A series of blocks and torches with even number of torches, because each torch negates the signal, and 2 negatives makes a positive. So if you have an even number of negations, then the signal at the other end will be the same as the signal you input. So if I turn this wire on, it will power this block, which turns this torch off, which unpowers this block, which turns this torch on, which powers this block, which makes this wire on after 2-tick delay, 1 for each torch. And the opposite is true. And this can be expanded semi-infinitely upwards. This does not transmit signal downwards. To do that, you could use this, or you could use the properties of repeaters to transmit signal downwards. Here we have a wire that is powering this block, which powers this repeater, which powers this block, which powers this wire, which powers this block, which powers this repeater, which powers this block, which powers this wire, which powers this block, which powers this repeater, which powers this block, which powers this wire, which powers this block, which powers this repeater, which I destroyed, which powers this block, which powers this wire. And I have each repeater set to a 4-tick delay so you can see the transmission, like so. And if I made the repeaters each 1 tick, it would only take 4 ticks till it's at the bottom of this tower. Fairly fast, but you can see 4 ticks of delay at the end. And this is also expandable semi-infinitely. And you don't have to worry about how many repeaters you have as far as negation purposes go, because the signal is only being repeated. It's not being inverted using repeaters. And then finally, I'm going to show a slightly more advanced application of this, which is slant horizontal signal transmission in a matrix slice like this. If I wanted to transmit signal to this redstone wire right here, and I start off with this torch here and this repeater here. This repeater powers this block, which then I can use to power this wire, which powers this block. Well, actually this block. It doesn't power. Let's see. No, it shouldn't power. Oh, it does. Okay. Well, sometimes redstone's quirky and it would not power this block, so don't count on it powering this block. But so powering this block below it, which I can use to power this repeater, to power this block, to power this wire below it. So there we have a slant horizontal. It's basically the same as this, but instead of zigzagging back and forth, we're just doing it in a horizontal line. Now, what if I wanted to transmit power from this wire here horizontally upwards instead of horizontally downwards? So upwards to here. And to do that, we're going to start with power. This powers this block here, which powers this repeater. I am totally contradicting what I said earlier about not counting this block to be powered. Well, it's powered. All right. You know what I'm thinking of? I'm thinking of this situation. Which I can't even show properly. But, so this block is being powered, which I will then use to power this wire. Now, this wire is powering this block But even though the block is being powered by the wire, the block does not give off power. And that's probably something I should have gone over back here, but now we're going over it. A block being powered by wire does not give off power. As you can see, this is not receiving power. No, well, that's receiving power from that repeater, nor is this. So I'm trying to get signal over here without messing up this matrix. So what I'm going to do is finally put another repeater here, which receives power from this block, because this block is being powered and the repeater receives power from it, which powers this block, which powers the wire. So there you have all sorts of signal transmissions, and that is the end of this video. Thank you for watching. This is BlackBerry Pi.